Hello, Emily. It's Friday, September 4th. And that's right, it's Friday, okay? Last time I made it a day late, now I'm making it, well, 2 days early, 1 day early, depending on if you actually believe me about making it on Saturday. Maybe I'll start making it on Fridays. I'm being very wishy-washy about this whole date thing. Sometime over my weekend, I will make these videos. So many sciencey questions. Oh my goodness, that's fantastic. You just give me all the topics. Can you just give me all the topics from now on? However, it is going to be really long, so I apologize for that in advance. Anyway, you brought up some very fascinating questions, which I will get right into. The first one, which I think may have been the most legitimate question, is what is temperature? Temperature basically is measuring movement. Basically, like if you think of a pot of boiling water, the temperature of the water is measured based on how much of the water molecules are moving around. How much the water molecules are moving around, or how many of the water molecules are moving around. Really, they're all moving around because it's a liquid. That's the kind of one of the definition-y things of a liquid. Anyway, how much it's moving. Each of the little things are going boom, 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 all over the place. Little atoms, molecules, like that. So temperature is saying how much are they moving, and then we say, well, they're moving this much, therefore. If they're moving a lot, we say it's hot. If they're moving very little, we say it's colder. Now, there's also like the differences between materials. Like some types of material, you can heat up more and they don't move around as much. But it's just a matter of how much energy you pound into it. And so, like, something that like a rock, the atoms and the molecules in the rock are not moving as much at 100 degrees as the water molecules are, because the molecules have different properties, but they still contain that same amount of thermal energy, which is what the temperature is. So how much movement you have depends on the material. However, if you compare like a tiny little vibration-y movement with a little more vibration-y movement, and whatnot, it's all relative to the material as far as how much it's moving. However, it's universally how much energy you're putting into this thing. That may have been a very bad explanation. I hope that wasn't too bad. It was kind of long and drawn out. Anyway, what are units? I think you meant in regard to temperature, and I think I kind of answered that, but I don't know exactly how the units are calculated, but they are calculated based on the amount of energy that is being pounded in / the amount of movement, which is all kind of the same thing in chemistry, physics-y stuff. Science. Anyway, okay, next question. If you made an incision and pumped the sealant full of air, would it explode? Well, if you took a balloon and pumped it full of air too much, would it explode? Yeah, it would. Because the air has nowhere else to go, so eventually it's going to explode. So if you made an incision, it depends on how good how small it was, like how tight it was, because is the air just like able to leak right back out? Because if not, it just depends on if the force of air pushing out on the sealant was greater than the tightness of the sealant to be able to hold together. But yeah, if you just kept pumping it full of air and you had, like, if you assume you've got a airtight or almost airtight incision for somehow, then yeah, it would. In particular because the sealant does not directly connect to the lungs, so it won't, like, go back out your mouth or your nose, because the lungs and the respiratory and the digestive tract and wherever are not, they do not flow into the sealant. That's kind of, you probably learned in biology that is kind of one of the things about the sealant, is that things don't pump directly into it. Like the stomach does not get emptied into the sealant, and things like that, which may or may not be an obvious statement. So in summary, yes. Assuming you were tight enough, yes. How can there be so much variation in elements when they're all the same thing? Yeah, that's sort of a really confusing question, because they are kind of all the same thing. However, at some point, they have to be made of the same stuff. And, like, if you think about it, you're like, well, what's this made out of? Well, what's this? If you break it down into smaller parts, at some point, you have to reach an end goal, if you know what I mean. You have to reach a point where they're made out of the same stuff. It's not like every single thing is made out of something fundamentally different. However, why chemically? Electrons take energy, they are energy, they use energy. Wow. All of a sudden I'm questioning my entire chemistry basis of stuff. They are energy, they make energy. They use energy. Well, anyway, electrons can like take energy, and that will cause them to move around, back to the temperature thing. But so depending on how they react to energy, that'll make them do different things, like stay solid or go to a liquid, or whatever. If like certain wavelengths of light go in, and certain levels of energy will bounce back, and you get colors and you get textures, and it just has different properties. That's so complicated. Oh, so complicated. Yeah, I don't know if I can answer that. The electrons are the difference, and the neutrons, and the protons. Sorry. Maybe I'll tackle that one next week, because that's a question. The disease on the moon question. They would have to probably be an extremophile if you expect them to, like, be alive and reproduce on the moon. However, that is not necessarily assumed in your previous statements. See, you could take, like, bacteria there or something that can just survive, not reproduce, but just lay dormant, make like the Martians, and just hang. They don't have to do anything, they just have to not permanently let their genetic material become compromised. So things like spores, they tend to just survive no matter what you do. So maybe they could survive on the moon. They just wouldn't germinate till they got back to Earth. One of the things that we use to kill spores, like in medical situations and whatnot, is pressure. And the moon is not a highly pressurized atmosphere. If you like sent it into some kind of I don't know what kind of planet has high pressure. Probably a lot of them, like the gas giants or something. But something with high pressure, you'd probably murder it forevermore. But like the moon, I don't think you would. I think it could just stick around for a while. However, I don't know exactly how hot it gets, how cold it gets. In which case, you might have to have an extremophile, plus maybe an extremophile that had the capability of going dormant. But in either case, depends on whether you wanted to like reproduce on the moon or just hang there until it hitched a ride back to Earth. So that's a kind of an important factor there. How do you strangle a horse? Really? Well, actually, I kind of have an answer for this one. So I can't necessarily say that definitively, but the other day in class, we used this rope to learn how to not strangle a cow. Like how to tie a knot that won't slip when you slip it over their neck so that you don't strangle them. So I'm assuming that if you did not use that knot and you used one of the other knots, that you would strangle a cow, and therefore you would probably also strangle a horse. So let me show you the knot that we did that will not strangle them first. And voila, you have a knot that will not slip. Well, actually it will slip until I tighten it up. But there you go, that's all that's slipping. So that's how you don't strangle them. If you loop that knot over them, theoretically you won't. Therefore, I must assume that the other knots we learned, which have a tendency to move, would probably, because they keep pulling and it just gets tighter and tighter and tighter, one of those knots. So I'm assuming that's how you strangle a horse. Make a knot that gets tighter when they pull. Okay, Peter Pan. Here's my assumption, based on my knowledge of chemistry for Peter Pan. Things, when you have very high concentrations of them, they tend to fuse into their surroundings. So basically, if you have very high concentration of something, it'll try to go to where there's lower concentration. So if you have very, very high concentrations of faith, hope, trust, pixie dust, what were it? Wasn't faith, hope, and trust and pixie dust. Ooh, wow, fail. Okay, anyway, that stuff. If you have very, very high concentrations of that within them, I have a feeling it would just, like, diffuse into the wood. And the wood does not necessarily have to be sentient. However, I think there's a high possibility, regardless, that the ship is sentient, or whatever you use as your example. But I think the ship very possibly could be. I think it might have its own personality. I think there's also a strong possibility that the ship was made out of one of the golden apple trees from, actually it wasn't in Narnia, it was in one of the other worlds. Where was that? You know what I'm talking about? The golden apple tree. You know what I'm talking about. The golden apple tree and the magician's nephew. I think it was made out of one of those. I think there's a very good possibility of that as well, which probably would act as a fine conductor for these pixie dust and related things. Yeah, so that's my theory. Are cicadas screaming trees? Oh, well, I don't think it would have taken us very long to figure that out, because people eat insects in some parts of the world, not everywhere. But I think people would have been like, what is that, and can we eat it? They fly around, and they're noisy, and they get in houses and tents and everything, so I think that probably would not have been too much of a problem. That's all I've got to say about that one. So, in regard to your comment about guns in space, I think there's much less likely if you need to use a gun in space for, protection, but I think it would make an excellent way if you're, like, stuck out heading toward the wrong direction away from Earth, floating, because you can't control where you're going because of the whole gravity and lack of atmosphere thing. You could probably use a gun you point it and the gun doesn't go that way, although the gun could go that way. The bullet goes that way, you would go that way, so you could possibly use it as a propulsion system. So I think that could potentially be very useful if you ever caught in the vacuum of space with a gun. That's what I would definitely use the bullets for. Okay, so I think that was all your questions and everything. I just did it again. I said so many times in the last one that I actually know what the vocal little zigzaggy line looks like when I say, when I go breathe, and I cut all to maybe almost all of them out, all of them that I heard, and I think I shortened the video by several minutes, very possibly, by doing that. So, you're welcome, and I cut out all my breaths just to save time because there were so many questions. Anyway, I hope the orange groves are treating you well, and I'll see you soon.